Alrighty, let's get started. Thanks for joining us in the 21st WMUG, no, Workplace NIA User Group Netherlands Tech Tuesdays. Just discussed the branding a couple of minutes ago. So welcome today with Patrick van der Born and Rick Stijnman, and they have a session about deploying Windows 10 with Azure DevOps, Terraform, and Packer, and really looking forward to this session. So welcome, guys. Before I give over to you, I would like to thank our sponsors, because without any sponsors, we're not able to organize events like this. The virtual events aren't that expensive, but hopefully within a couple of months, or maybe in the second half of this year, we will be able to organize some on-premise events again. And I know that a couple of sponsors are already approached us to organize something. So hopefully we can make it happen. So thanks for our sponsors. If you would like to follow us on Twitter, Meetup, Facebook, YouTube, or LinkedIn, here are the links. If you want to tweet, use the hashtag WPNIASNL, so we can follow you back and maybe retweet you. We have some upcoming events scheduled. So next week there's another live Ask Us Anything with Ronnie and Franz. And this is the Microsoft Ignite edition. So all the new stuff around which is released during Ignite earlier this month will be covered. On the 30th of March, Dirk-Jan Mollema will join us with a security-related session. Also really looking forward to that one. And then April, Greg Ramsey will join us.
Ja, goed.
And
Ja, zeker.
Somebody's phone call is recorded. Greg Ramsey, good friend of mine from Seattle, will join us with a session about automation in the workplace area. So if you want to talk, also if you have a session and you would like to present something at our user group online, or if we are back on premises, submit your session. We are here to help you. So if you're not that experienced, we can help you. If you need coaching, we can help you. If you are really experienced, you don't need help, but we are happy to have you. So submit your session, and you will definitely end up here like Rick and Patrick. So with that, guys, I want to hand over to you. Have fun, and if you have a question, use the chat or unmute. And if you have a question via the chat, we will chime in and ask Patrick or Rick to answer the question. So the floor is yours.
Okay, I will take over the screen sharing. So hopefully I see Rick. Okay, he's there. Yeah.
Yeah.
Yeah, I'm here.
So do you see my screen? Yes. Okay. So So welcome to our session, deploying Windows 10 multi-user on Azure with Azure DevOps, Terraform, and Packer. And Rick and I are doing a cool project at a bank in the Netherlands. And we started it, I think, in September. We were traditional administrators, and we moved to a DevOps approach. And in this session, we want to give you an overview about the organizational things, how to transform into a Scrum Azure DevOps organization, and some technical fun with Azure DevOps, Terraform, and Packer. So who am I? I'm Patrick van der Born. I'm an independent consultant in the Netherlands. I'm active in the community, so I'm a member of Team Remote Graphic Experts. So virtually I'm a GPU geek. I also do some performance researches for Go EUC, and I'm rewarded as a Citrix technology professional. So if you have any questions or want to have a conversation about this presentation or this topic, you can also reach out to me after this session by email, Twitter, connect to me with LinkedIn, or start reading my blog post. And yeah, I also bring my partner in crime in this project, Rick.
Yeah, thank you for having me, Patrick. My name is Rick Stijnman. I'm an engineer at a big Dutch national bank. You can find me on Twitter, LinkedIn, and my website. And yeah, we started this journey together, I believe in September 2019, where we hired Patrick, and we're on this journey from the start together, and we've got a lot of experience to share with you. So if we go over to the agenda, I'll start with the journey to DevOps Scrum approach, and later on we'll talk about Windows 10 via the Azure DevOps pipeline, and we go into infrastructure as code with Terraform, fun with Packer for image as code, and yeah, of course we've got some time open for Q&A. So our DevOps journey. So I'm from a bank, financial institution, and yeah, we started our DevOps journey back in 2019, where we were used to work with Kanban, moving cards from open to closed, from left to right on the board on a daily basis. And in 2019, the infrastructure department and the workplace services really started with DevOps teams. And basically that meant for us in reality that we put the dev and the ops guys together in a single team. And it doesn't make really DevOps yet, but it was at least a start. So in 2020, we started by implementing the Scrum framework. And that meant that we introduced product owners and Scrum Masters, and the product owners were responsible for the backlog. And because we're a big financial institution, we've got multiple product owners, so also those are linked together. But still, we're seeing that it was a bit of a split between dev and ops. So from 2021, we started with the real DevOps. Agile was more introduced, and that we start by moving from traditional IT to automate everything via Azure DevOps. Yeah, and that's basically our journey. We're in the middle at the moment.
Hey Rick, and why is that transition so? Yeah, why is it needed to go from a traditional administrative department towards a DevOps approach?
Now, I've got some slides later on for the benefits, but basically the time to market for each product or services is far more shorter, and we can deliver more output with less people.
Cool. Okay.
So in a traditional way, this is what we did for years. We had an engineer, and then we throw a project to him. For example, create a server to host a service, and he started basically in the dev environment by testing it out. And then he goes to the UAT environment to do acceptance testing, perhaps put some users on to confirm that his test results are good, and then he moved it to production. And every step along this way, he had to do a repetitive task. He had to install the server in the dev environment, he had to install the server in the test environment. And even though that the engineer had some automation there, there was still some room for error, because repeated tasks, not infrastructure as code, always could possible give some issues by the human interaction. That's something we try to avoid. So moving this to translate this into a DevOps way, I've got another slide. That's making the use of Azure DevOps. That's a tool for us within the bank. If you can click, Patrick.
Sure.
Is that we use the repositories to store our configuration, and that we split our configuration already, that we make it variable, so that for each environment we've got parameters. So if you look at my previous example and you go to the to this way of working, then you see they store everything in the repository, and the pipeline executes that towards the environments. You see below the pipeline, and then you can put that configuration with the parameters to an environment. And the nice thing to do is that you can add a test plan to it. And with a test plan, you can confirm your output. And we do that the same for the user acceptance testing, just the same configuration with different parameters. And then the last stage is then production, also included with the test plan. That's basically the way, the DevOps way.
Cool. So if you automate things, then you will get rid of the human errors. That's cool, man.
Yeah, that's cool. But the other thing is that you've got lots of systems, and if we're from a Citrix background or WVD, or you're from file and print, it can be that you use PowerShell, and what's really common in our area. But it can also be that your product uses, for example, VMware CLI, or you need to use it's also with PowerShell. But you can also think of configuration like Python and whatsoever. YAML is needed for those pipelines. So that makes it fun. More languages, more scripting, more automation is equals more fun. So going to the next slide here is the DevOps way. Now, why are we doing this? Now, it's faster delivery of the configuration. By planning sprints, by adopting the Scrum framework, you see time to market is short. The quality of the configuration is higher, there's no human error there. And the most fun thing for me is the less repeated work, because you code it once and then it doesn't matter how multiple times you roll it out.
So you have more time for the fun job.
Yeah, exactly, for more coding, yeah. Less foreseen issues, we already see that now. If you do it good, and that's my approach, is if you do DevOps really good, then you go from DevOps to NoOps. That's the next step. There will always be some operational tasks there. It goes hand in hand with Dev. But the thing is to bring the cost down. Work is changing. For years we're good at clicking and following server operating procedures, but we're going from clicking to coding. It fully adopts into the Agile and the Scrum framework. And one of the other things, what I like about it, is that we're going into the process-focused approach instead of ad hoc responding to incidents. Process folks, also if you automate something, and we'll see it later on with Terraform and Packer, you've got very interesting slides there. But also in that pipeline, we also think about how do we adopt this in our ETL processes, how do we need approval for certain stages, so that process is also really important. And the last thing, make mistakes, that's really needed. I made a lot of mistakes, and sometimes I had to throw stuff away and just redo it. But there should be room for that, to learn and improve from your mistakes, and that goes hand in hand with this whole project.
Yeah, Rick. So you've turned from a traditional administration department to a DevOps department. And I know a funny story about your journey. And can you tell us something about this funny story, like a traditional next finish, what also I did?
Yeah, I shared this already with you. The thing is, when I started this project, we started with a proof of concept to have Citrix in Azure available, and we've got a cloud department who will help us bringing our stuff to the cloud. And I needed basically a VNet with express peering. And I went to one of the networking guys from the cloud team, and I said, okay, I need this. I need a VNet. I need to have it paired with the Express. so I can start using and building in Azure. And basically he responded to me, he said, okay, go to this repository, fork it, adjust the YAML pipeline, do some commits, put in your parameters, make a build pipeline, run it, and there you go. And I was like, okay, guy, I'm working for 15 years in IT. Are you speaking Chinese or what's going on? What did I miss? And then he really explained me the DevOps way, how to do it. But all those bingo words you see now on the slide were new to me, like cherry picking, pull, push. But also during the project, we found out that we had to find a branching strategy for our code, because we were working with multiple people on different things, but also on the same code, and we had to find a way. So what it means for us, and especially for me, is that we changed from a traditional IT to a developer.
So was that hard for you? Like it was really cool, just forking it and then running through a pipe, and then ta-da, we had a peering. Like whoa.
Yeah, it was really cool to see. But then the thing for me is, if I see something, I want to understand it. I want to get my head around it. How does that work? So then our DevOps journey really started. I still love it. And I think you also came along with this project, and there are still nowadays some days that we think, okay, what's going on here? But if you talk to people are in our organization very helpful, and I'm also sharing the lessons learned from my experience to different teams within our organization. So you see a broader adoption of DevOps in that way. But overall, I've got a good feeling about it. I see it's very efficient. I think it's really cool. It's changing our jobs. It's changing the way how we do IT. I think it's a good thing.
Yeah, and also it's very cool if you just deploy something in 10 minutes, where you was thinking about, hey, maybe in the past it was 2 days work.
How long did you build up the Australia East test environment?
Yeah,
we had a request, there was nothing, and then
15 or 20 minutes later we're done.
Yeah, so that's really cool. And then reusing the code, that's really nice. Yeah.
Okay, so the DevOps journey started, and hopefully we give you some insights about what it is also for Rick to transform, and me also, from a traditional guy to a DevOps guy. And I think we can say in the upcoming slides that we're more like ops guys than dev guys, so not a 100% developer. But I will take you with me with the journey of the technical stuff itself. And before we do it, I want to set some kind of context. And we are doing a project where we're migrating the on-premises VDI environment towards Microsoft Azure. And we're doing it from a single user VDI to Windows 10 multi-user. And as you know, the Windows 10 multi-user is only available on Azure. And we are using Azure DevOps pipelines. And since Azure DevOps itself is a session alone, I will not go that deep into Azure DevOps, and I hope in the upcoming slide that I will keep it on a high level, so you get a picture about how a complete project is executed via pipelines. So in our project, we defined three areas of code, and our teams are working on a piece. So for example, Rick and I are now very busy with the infrastructure and the images code, and another team, for example, the desktop as code. And we are also think along with that, but our primary focus at the start of the project was just infrastructure as code and images code. And with infrastructure as code, we are using HashiCorp Terraform. For the images code part, we are using HashiCorp Packer. And for the desktop as code part, we are using Citrix PowerShell, the SDK, or Citrix with the APIs, which are now available for Citrix Cloud.
Which is really a good thing. So thanks to Citrix for that.
Yeah, the APIs, it really.
Yeah, the APIs are really great. Yeah.
So if you think about infrastructure as code, you have to think about in Windows 10 multi-user session, even if you're doing WVD, about deploying, for example, your Azure files, where you store your FSLogix profile containers. Or maybe if you have to onboard a lot of people, you have to dig into the ADAP NetApp files. You also have to deploy things like the Azure networking, so the VNets, subnets, the user-defined routes, and even the peerings. Maybe some key files, key vault, where you store your secrets, which you can also use in pipelines if you want to set, for example, the local admin password, or your Azure shared image gallery to store your Windows 10 multi-user images. And since we're doing Citrix, we're not using the WVD brokering part, so we also deploy the Citrix Cloud connectors and the Citrix Federated Authentication services. And we try to configure everything as a redeployable item. So for example, we can redeploy the Citrix Cloud connectors, and we will do it very frequently. So we do not patch it and update it. Instead of that, we redeploy it. But for some other pieces of the infrastructure as code, so for example, the FSLogix shares, that doesn't make sense. So if you have 8 terabytes of profile containers in there, it doesn't make sense to destroy your Azure NetApp files, redeploy it, and then restore a backup of all the containers, for example, on a frequent base. But if it's broke, we can redeploy it to start from scratch. If we look at the images code part, we are using HashiCorp Packer since we still have some needs of some super secret applications which only allows to run on bare metal in in the banking environment. So we need to deploy some images, for example, on VMware vSphere. So for the RDSH, or in Citrix terms, the SANAP part on Windows Server 2019. We also use it to create our Windows 10 multi-session images. And in the near future, we want to look if we can also deploy this on Amazon AWS, for example. So that's why we choose the HashiCorp Packer framework, and I will dig into this later in this session. For the Citrix, for the desktop as code part, we configure everything via a pipeline. So for example, the machine catalog, which is an equivalent of a host pool, we do this with Citrix Push and API, but it's not in this session. But hey, this is a Microsoft community. You can also do WVD as code, maybe that's also desktop as code, and you can use, for example, HashiCorp Terraform, and to deploy your host pools, your workspace, or your application groups. And maybe if something is not in the Terraform part, you can also use the WVD PowerShell or ARM to finish your configuration, also via pipeline, via the same methodology. So the goal of our project is at first to onboard 4,500 users in Azure. And we start now in Australia, and we will do it very soon in Europe. And our goal is to do everything as code. And our main tool for that, as we I think mentioned multiple times right now, is Azure DevOps pipelines. And we're only allowed to use YAML pipelines, so no GUI clicking. And we're also limited in only using the build pipelines.
Why is that?
Yeah, there are also release pipelines in Azure, and the release pipelines are only GUI based, and we are storing the YAML pipeline also in the Git repository, so we have some kind of source control over the pipeline, so you can refer it. And the other goal is to have zero-touch interfaces, so we cannot have any admin rights in Azure and Citrix Cloud, so we can only change things via Azure DevOps.
Patrick, can I ask a question?
Of course.
So what is your experience in regards to the build and release pipelines? Is there a reason why you're not using the release pipelines from Azure DevOps?
Yeah. That's we started in our first journey to understand the things, and then our cloud department said, hey, it's not allowed to use the release pipelines since you cannot store that in a YAML file.
Okay, that makes sense. It's only GUI.
Exactly, only GUI, just via the GUI, and it's mandatory for us to store the pipeline configuration in a source control system.
Yes, because you want to make sure that everything as code is stored in a repository as well.
Exactly, and that's why we can't use the release pipelines since there's no versioning control.
And everything what's being done in a release pipeline can be done in a build pipeline. So there is no
Yes,
reason
that's what I realized as well. So I was just wondering what your lessons learned was. So thanks for that.
Yeah, in our environment, it's our best practice, basically.
Yeah. So yeah, when we start the project, we use it for 2 weeks, and then we never use the release pipeline anymore.
Yeah.
Makes sense.
Sure.
Thanks.
You're welcome. As the first technical thing, we are going to dig in infrastructure as code with Terraform. And yeah, I can also spend 3 or 4 sessions about Terraform, and yeah, it's really cool stuff. And I first want to share with you why we choose HashiCorp Terraform in our project. So if you look at the Microsoft platform, so we're now deploying only on Azure, is that Microsoft has the ARM method to deploy things on Azure with ARM templates, and also now have a project called Project Bicep. And I've seen a lot of Project Biceps, and the syntaxing looks very familiar if you dig into Terraform. But one downside of using the Microsoft tools in our project is that it has no multi-platform support. It's only Azure only, and we also need to deploy this, for example, on Azure, vSphere, and maybe later on AWS. So that's why the main reason we chose Terraform. And on the other hand, when I first started with Terraform, I was 1.5 hours away, and then I was able to start with an empty Terraform file and deploying my first virtual machine on Azure. I also tried that some years ago with ARM, and yeah, that was very complex for a beginner to understand how ARM works. If you talk to an ARM geek, he's telling me like, okay, ARM is not that complex, but hey, then you have a steep learning curve and some experience with ARM. On the other hand, in our project, we have a lot of beginning ops engineers in the dev world, and for us, it makes more sense to use Terraform. So the language for deploying things on Azure or AWS or vSphere is exactly the same when using Terraform. And so they get used to the Terraform language, and they don't have to dig into Bicep for Azure, or I don't know what they're using in AWS, maybe also something like that, and get control of all those different languages. Later on in the slide deck, you also seeing the redeployment and the plan stage. This is also for approving deployment of infrastructure resources. It's very handy, and you will see this later in the slides. So if you dig into the Terraform website, the documentation is pretty good. It's also open source, and if you go to the providers, that's how Terraform calls where to deploy. So, for example, if you want to deploy on AWS, it's possible, but also, for example, on Azure Stack or Azure Active Directory itself, or if you have a use case, deploy it on Alibaba Cloud. Just click on the provider, and then you get into a well-documented overview how to deploy features on that platform. And we are also very interested to deploy it on VMware vSphere. And there are some different type of providers. So here's some kind of medallion, and it's by HashiCorp. So you've got providers who are created by HashiCorp and maintained by HashiCorp, and you got providers which are created and maintained by the community, and are verified by HashiCorp. So yeah, we are only using the HashiCorp certified providers. So we dig into the Azure provider. I can make a slide or also a screenshot on the left hand side. These are all the services you can deploy with Terraform. So yeah, they're almost everything which you can deploy with ARM. I think there's a lot you can also deploy it with Terraform. So for example, attestation services or blueprints or a CDN or cognitive services or data explorer. Yeah, there are a lot. You can scroll a lot over there. If you just dig into my area, there's also a desktop virtualization. I also mentioned it earlier, but hey, here you can see how easy it is to deploy a host pool, and I will dig into the language later on. So, how does Terraform works? Yeah, it's really an easy language. It's called HashiCorp Language 2, and basically what you do is you start with if you want to deploy a resource, with resource, and then what type of resource. You can find this in the documentation, and then you give it a label. So, for example, my first Azure virtual machine. If you look into the documentation, you see what type of values you can specify with the deployment of a virtual machine. So, for example, the name is my first Azure virtual machine. And the resource group name. So where is the virtual machine deployed? And here is the power of Terraform, is that I can make a link. So for example, if I deploy a resource with Azure Resource Manager Resource Group, which with the label main, I can I can link it by just saying Azure Resource Manager Resource Group .main, which is the label, and the name, which is the name here. So if I changed the resource group name later on in my code, then the deployment of my virtual machine will automatically be changed in the new name of the resource group. And the same is for the location. So I've linked here the location of the resource group, so my virtual machine is also deployed in West Europe. I can also specify, this is a very simple example, the size, for example, the username, password, a network interface card. So this is a link with my network interface card. What source image is used? So I'm deploying here a Windows Server 2016 data center image from the marketplace images with the latest version, and what type of operating system disk is used. And these are the only lines you need to deploy an Azure virtual machine. Before I switch over to the demo, I want to tell you some common Terraform commands. So basically, there are a lot more, but when you start with Terraform, there are 4 commands you need to know. The first one is Terraform init, and if you download Terraform, it's just one executable. You can download it on Windows or Linux on your Mac, or it's even there in the Azure CLI if you want to use it. If you uploaded your Terraform infrastructure as code, you can start Terraform init, and then Terraform will read the configuration and download all the dependencies before it can actually start the deployment of the resources. So for example, if you configure the provider Azure, it will download the Azure connector, so it's capable of connecting to Azure. And if you, for example, define the AWS provider, it will download all the dependencies for the AWS provider, so you can deploy resources on AWS. So the next stage, it's not mandatory, but hey, I always do it, see it like a what-if scenario, and you'll see it in the demo in just some minutes. You can start with a Terraform plan. And a Terraform plan is like, some kind of what-if scenario. So Terraform will actually look into your platform. So let's say Azure, and see what resources are there versus what you configured in your Terraform configuration. And it will tell you exactly what it's going to do if you want to apply your Terraform configuration. So for example, if you change the name of a resource group, it will redeploy it and tells you like, hey, I'm now first going to destroy it, and then I will recreate it. Or if you change a tag, then it only says to you like, hey, I'm just changing the tag of this virtual machine. And you can investigate this plan, and if you're happy with it, so for example, if it creates 32 items and destroys nothing, you can apply this plan file. Terraform will have a plan file, and you can apply the resources, and that's the point. If you do Terraform apply, which will Terraform actually will deploy all the resources on your configured platform. Now, if you're done with everything, and we use this, for example, for our Citrix Cloud connectors, if we want to redeploy everything, you can also do a destroy. Terraform will ask you, are you really sure? And if you do yes, it will destroy all the resources which you have configured in your Terraform configuration. There are some files used by Terraform. You will also see this in the demo, and the TF file, that stands for Terraform. This is where you specify your infrastructure as code, like I showed you with the HashiCorp language too. You can also have a Terraform vars file, which is actually a file, so you can specify per environment different variables, so you can reuse your Terraform infrastructure. When you do a Terraform plan, it will output a Terraform plan file, and that file you can use to just apply the file. So when you do, for example, a Terraform plan, and you will wait for 5 days, like someone needs to approve the changes you've done in the Terraform configuration, and you apply the plan, and in the meanwhile the environment is changed, Terraform will see that and say to you, hey, the real life environment which you now have on Azure, it's not the same as specified when I've run the Terraform plan, so I will not apply the changes. You need to rerun the Terraform plan to have a good plan file, so you don't apply things which you don't expect. The last one, that's a very interesting file. So Terraform state file. When you apply a Terraform infrastructure as code, Terraform creates a Terraform state file, and a Terraform state file is just a mapping between your configuration in your TF files and the real world. So the first thing, if you rerun your configuration, Terraform will use the Terraform state file to check if things are still on your platform. So for example, if the resource group still exists, and if there are new things in your Terraform file. So basically, if you have problems with your TF state file, you're a beep. then you need to do some things to repair it.
But Patrick, does it mean if you plan something without Terraform, can you import it later on into Terraform?
Yeah, it's possible. So if you started with deploying things by manually, you can use import, Terraform import. That's a 5th command. And then if you know the ID, for example, of your Azure resource, then you can import it into your Terraform configuration. So if you start building your Azure infrastructure without infrastructure as code, it's always possible to introduce Terraform after you started manually. So I will give you a little demo, and I hope you hear the sound about how we do it Terraform with Azure DevOps and deploy this on Azure.
Okay, welcome to my Terraform demo, and as you can see here, I've specified on a repository, and I added it with Visual Studio Code, how to deploy the Citrix Cloud connectors on Azure. So we got a main file. In the main file, our backend is specified. So in this example, it's Azure, and it can also be, for example, AWS or vSphere. We will deploy an availability set, which will where the virtual machines will reside. We will deploy a key vault self-signed certificates, and these self-signed certificates are placed in a key vault which already exists on Azure, and this self-signed certificate is used to connect with WinRM HTTPS to deploy software on the deployed VM Azure. Network interfaces, and I will show you later on in this demo added a count here. So for example, how many network interfaces are deployed. So if I specify three times this network interfaces deployed in Azure. A resource group where all the resources are deployed. the virtual machine itself, which SKU version, which OS disk, which OS profile, the time zone, the WinRM protocol with the certificate, and yeah, some tags. I will also import some existing data. For example, I cannot redeploy my virtual network with its subnet since it's deployed manually as a path with a peering. And my key vault, I don't want to redeploy my key vault. I have some output, so when the Terraform is finished, I will get the VM name and the IP addresses, which is created by Terraform. The variables from TF, and I declare all the Terraform variables in here. And I got my variable file. It's TF-vars, and it's a little bit funny. I will show you on the pipeline deployment. Is that the you can specify a Terraform. We specified workspace. You deploy it in a workplace. Terraform will use the mapping variables for that. So for example, if I specify UAT, then the environment letter or every will be A, or the cloud connector amount for UAT will be 2. And for development, for example, 1. And if I specify the Terraform workspace UAT, a D2SV4 is used for the deployment on Azure. Also the standard SSD, and when we do production, the premium is used. And the same is for the start of the host number. And we can specify all the variables in the Terraform vars file. So let's go to Azure DevOps. I've created a multi-stage pipeline here. It's called a Born CI/CD demo. And if you see the last pipeline, I deployed it to the development environment. It's a multi-stage pipeline. So the first pipeline is to do the Terraform plan. And the Terraform plan is like a what-if scenario. So when Terraform plan runs, it will give you an overview of what resources will be created, changed, or destroyed. This Terraform plan file is added as an artifact to the pipeline. So when the next stage, the deploy Citrix backend, which has a dependency of a check, which is actually an approve. So when the approver approves the changes, which is published in the TF plan artifact, then the actual deployment will start based on the TF plan, which is copied back from the artifacts. So since we've done this in development, I will now set up a UAT run. So I will do it from the master branch. I will do it for UAT. This is where my TF state files are saved. So this is actually a storage account in my Azure subscription, and we will press run. The pipeline will start running, and I will fast forward it to the actual point that the Terraform plan has run. So the Terraform plan has run, and you see here that it will create a lot of resources. A to add, a 0 to change, and it will add 2 cloud connectors with an A name. I received an email that I need to approve the stage to deploy the actual infrastructure in UAT. So when I go back to the pipeline, you see that the second stage is waiting. And I can put review. I'm the approver, like good job, and deploy stuff. And then we press approve. Now the deployment pipeline will start, and I will fast forward to the point that it will actually is starting to deploy resources. And as you can see now, Terraform is creating resources on Azure. I will fast forward to the point that the resources are created, but when you see here is refresh, there are no resources yet for the cloud connectors, and I will fast forward to the point that the actual deployment is finished. So as you can see now, all the resources as described in Terraform are created on Azure. The pipeline is still grabbing the Terraform state file, but if we go to Azure, we see that the resource group West Europe Infrastructure C2 Cloud Connector UAT is added with their resources in it. So now we can test this for the user acceptance testing. And if we want to deploy it, for example, to production, we can run the same pipeline and say like, hey, put it to production green, and then press run, and then it will do exactly the same for green. So thank you for watching my demo.
So that was a demo how we've implemented Terraform with Azure DevOps pipelines to deploy resources on Azure. So maybe if you have questions or later on, please reach out. So the next part is this Terraform is only allowing us to deploy some resources on a platform. But hey, we are doing Citrix, so we're building a Windows 10 multi-user desktop. And I think this is also the same for WVD. You're also building a Windows 10 desktop, but only using a different broker. And we are using Packer to build an immutable image. So again, why we choose Packer, like Microsoft also introduced now, it's recently GA, the Azure Image Builder. And again, for us, it's very important to have the multi-platform support in Packer language, it's called builders. And for now, we need to deploy this on vSphere and Azure. And if you're looking into the Azure Image Builder, it has a giant vendor lock-in at the moment. You're only capable of deploying images on Azure. And both are images as code. And on the left side, I stated simple. On the right side, I've stated complex. But if you look at the Azure Image Builder, it's basically built as an umbrella around Packer. So it uses the Packer engine, and they created something to use it with PowerShell and ARM templates. And I can get it because they can eventually add it to the portal as a GUI. But hey, we are doing images code, so we do nothing with GUIs. So just stick with the, in our opinion, stick with the manufacturer and not with the umbrella. So that's why we choose Packer. Packer is very simple. We configured it with JSON. Packer just released a new version with 1.7, and they also transformed to HashiCorp language 2 code like Terraform. So hey, that's the same. But basically, if you deploy an image definition, which is called a Packer template, you have 3 sections in your JSON file. The first one is variables. So for example, the Azure AD application ID. And you can reuse that. So the second section is builders. And builders in a Packer world is just a VM, which is used to create your image. So in this example, I'm using an Azure ARM builder to deploy a virtual machine on Azure. And for the authentication, I use an Azure AD application ID. So that's an SPN for that. The last part, it's called provisioners. And provisioners, in my world, it's more like a task sequence. If you're doing SCCM or Ivanti automation or a LAN desk. This is just the way how the Packer will install things on the builder. So for example, here, it will just run an inline PowerShell script and then uploads a file to the builder. So again, a Packer builder is a machine which actually built the image. And if you look to the different builders, and these are the most common, so you can deploy it on Ali Cloud, on Azure, on GCP, even Hyper-V, Nutanix, VMware Workstation, vSphere, and a lot of I don't know. I never heard of it. And lately I chatted with someone which was using Proxmox, so I've heard about it. And yeah, from the community supported, since I'm a Citrix guy, it's also a community supported builder to connect to virtual machines on Citrix and server or Citrix hypervisor.
And Patrick, do you think
Yeah.
it's easier or harder if you look at the code? I know you've got experience with Ivanti. I do have some experience with SCCM and those star sequences. What's your general opinion about this packer?
Yeah. We started this journey. Our bank is also using SCCM, and we had some problems starting to use star sequence with SCCM from a pipeline. Since we need to wait for the task sequence to finish. And in my opinion, when you use, for example, Packer, or maybe in the future Azure Image Builder, which is also a nice product, it's more code focused, so you can use it in the pipeline. You will see this in the demo movie. So I think that's the beauty of Packer. Yeah, and it's also amazingly it's free. I don't know why, but
But for example, if Citrix releases a new VDA, some core component, what we really need, what can I expect when it's in the image? The whole process?
Yeah, we will dig into the process later on, Rick.
Okay.
So if you look on the provisioners, that's the section which is actually the task sequence. The builder here on top will control the provisioners, and for Windows imaging, you have actually 4 types of provisioners, like file, just upload and download the file to the builder VM, PowerShell to execute the PowerShell script, Windows Shell to execute the command script, and Windows Restart, reboot the builder. Sometimes if you install a piece of software, you need to reboot. There are also other options, for example, to use not native PowerShell, but use, for example, an Ansible playbook, or Chef, or Chocolatey, or Puppet, to specify the desired state configuration of your image. And in our project, since we are shifting away from ops to dev, we chose to use PowerShell and maybe look into Ansible later on. So for example, if you use PowerShell, these are 3 types of PowerShell scripts we give to the builder via Packer, like install FSLogix, Office 365, and Teams machine-wide installer. And we can also specify if we want some environment variables. So for example, if you need to pass additional configuration to your script, you can use it as an environment variable, and you can use it in your PowerShell script. You can also specify in which context it needs to be executed. So if you need to log in with a specific user to install software, you can specify that context. And we are using a lot of pipeline variables to fill our environment variables and fill our scripts. But the big picture will be at the end of this topic. And when the task sequence is done, the image of the builder VM, a copy of the VHD is copied to, for example, a managed image in Azure, or your shared image gallery, or Citrix expects a VHD on a blob storage account. And you can use this image as a start, for example, of deploying your host pools or your machine catalogs. So I will give you some kind of demo here, how we integrated this in a pipeline.
So welcome to my Packer demo, Packer with Azure DevOps. So in our project, we are delivering our images via Packer, and we're using that in combination with Azure DevOps and with our own hosted Azure DevOps agent. So if you look to our agent pools within our Azure DevOps subscription, you can see we are hosting our own agent pool called Windows Azure NPM, which is a virtual machine in Azure which can directly communicate with our Packer builder, which we are going to deploy with Packer, and therefore we don't need a public IP for our builder machine. So this is safe to deploy. We are using Git within Azure DevOps to save our Packer template. And I will switch over to code. And you see the Packer template here. This is where we deploy a Windows 10 20H2 multi-session image on Azure. So as explained in the presentation, is that the Packer template has 3 sections. So the first section is variables, and variables are specified here. So for example, I got an Azure AD application ID variable, or an Azure AD tenant ID, or a golden image name, or the Azure DevOps build number, which we are using in the Packer template. As you can see here, the variables are defined with no parameters, since they're specified on the pipeline, and they will be filled with pipeline parameters. And if you want, you can retrieve the pipeline parameters from a key vault. So for example, your Azure AD application key or your local admin password. The second section is builders. This is actually where the deployment is done. So as you can see here, the deployment is done within Azure. And you can see also here is that the user variables, which are specified on the top of this Packer template, are reused over here. So these are the specification of our Azure Builder VM, what OS is used, how the communication is to the VM. So we're using WinRM with SSL, the username to connect, the virtual network and other types of this VM, this temporary builder VM on Azure. So we're doing it in my lab with a standard B2MS. That's not that fast. And where the image is saved, in this example, on a storage account called SA Born IT CICD Images West Europe, and a tag which is added to the temporary VM. Here you see the provisioners, what to install, and this is actually like a task sequence. So at first, a local admin account is created on the builder VM, and we are passing an environment variable which contains the local admin password, which is grabbed from the pipeline. Then we do domain join, so the builder is joined to the domain, and this is what we do for Citrix. After a domain join, we do a Windows restart, so the builder VM is rebooted. And then we were executing an inline script, which actually installed Chocolatey. And then start a new PowerShell session and install Notepad++ and 7-zip on our base image. You can also pass your own scripts, which we're doing here. And this is actually here, push install domain join. Okay, let's run this. So I have a pipeline here called Windows 10 EVD 20H2. And then run pipeline. And we're running it on our own agent pool from our master branch. And we press run. So the Packer build will start here. So we will fast forward it to the moment the Packer build is starting. Okay, as you can see, it's starting to build the immutable image now with Packer, and you see it's now deploying temporary resources on Azure, and you can see them and identify them with the PKR abbreviation up front. So if we look in Azure, we do refresh, and you see here that there is a key vault, a network interface, and a virtual machine. And those are used during deployment and are deleted when the image is subtracted from the VM. So the builder VM is ready on Azure. You can see it here, and you'll see that the DevOps agent is connecting with the private endpoint. So this is actually the private IP of the builder VM, and it's connecting via WinRM, and it's now adding the local admin and joining the machine to the domain, and will execute the rest of the installation. And here you see it's installing Chocolatey and Notepad++ from Chocolatey, and 7-zip as we specified in the Packer template. Okay, as you can see now, the immutable image build is done. And if we look at Azure, all our temporary Packer resource groups are also gone. And if we look at the storage account, we see that there is an image which is created now, and it's 127 gigs. And this image we can use with, for example, Citrix machine creation services to assign to a machine catalog.
Okay, so if we get back to the big picture of Packer, so on the left-hand side we have the Azure repo Git, and the first, and we're using Azure DevOps agent self-hosted, since we not want to use a public IP. So at first we download the repository, then Packer is installed on the self-hosted Azure DevOps agent, and then the Packer template, in this example JSON file, is used to provision a builder VM, in this example Microsoft Azure. Then at step 5, Packer waits until the builder VM is ready, and then uploads PowerShell scripts in our example, and then execute it. So all the PowerShell scripts are executed on the builder VM. And from a PowerShell script, we are using Azure Files, where the executables are stored. But you can also use, for example, the PowerShell Evergreen module, Chocolatey or WinGet to pull the latest version of an application and install it on your builder VM. And if you are using an Azure file and you want to be sure that nothing's changed there, you can also store the file hash on your GitHub repository and compare it before running, so you're sure that the same executable of your Azure files is used during setup. When the provisioner section is completed successfully, then the disk of the builder VM is copied as a golden image to your shared image gallery or your VHD in your storage account. So this is the way how Packer works in DevOps. So for this session we had some more time, so I added some additional slides. And if we look at the Packer builder, we also think about, hey, how can we do this smart? So we can reuse the Packer template over and over again. So for example, if you have the provisioner section, we can change the builders to deploy exactly the same image, for example, on vSphere or on AWS. But hey, what if we want to reuse the application in different images? And this is where we thought about layers. And this was like, hey, a Packer template, it's an image template. And where did I hear that before? And I know this is not the Citrix community, but hey, when you're a Citrix guy, you know about Citrix app layering. And the Citrix app layering is also called an image template. I think, hey, this is some kind of the same we can use with Packer. So what we basically did is that we are saving the Packer image templates in a folder in a GitHub repository called Packer templates. And this is a description of our image, like Citrix app layering. We also defined a layer called PS modules, which is our intelligence of all our installation scripts. So this is the first layer of our Packer image. The second thing is that we define install scripts. In this example, install fslogics.ps1 in the platform layer. And when you use the install fslogics ps1, there is absolutely no intelligence, only some kind of variables filled in where the executable is found. And the first thing of the script is to use the modules where all the intelligence happens. And we can reuse all the scripts in an image template. So for example, if we need to deploy an image in the US, we can just grab the PowerShell scripts here and recreate the JSON files and specify it for US. And we think in the future that somehow we want to automate the creation of this Packer template. So some kind of click and collect. Click your own image. I'm an end user just going to a portal and clicking all the software together, and then your Packer template is generated. Or for example, we are doing a lot of developers, and I don't know how, but maybe we have a procedure so they can make a branch of our GitHub repository, and then they add a package to an image and then create a pull request, and we just have to approve it, and then they have a new desktop in the cloud. But that's future stuff. So if we look at the layers on the left side, you see my tools I'm using at application layering sessions, and we described the following layers. So the 0 layer is called PS modules. For example, this is the first layer, and the module.psm1 is used there and uploaded to the builder VM at first. The second one is the OS layer. So these are the installation scripts where the operating system level. So for example, GPU drivers, if you want to create a Packer template for an NVIDIA or an AMD type of virtual machine, language specs. And the second type, and this is interesting, is a platform layer. So here is where we specified, for example, the Citrix VDA, or the WVD agent, or the VMware tools, or the Horizon agent. So if you want to switch from a platform vendor, you don't have to do a lot of changes. Just get rid of one agent and introduce the second agent, and then you'll migrate it to another brokering vendor, for example. The application layer, this is where all the scripts are stored for our general applications like Office 365, 7-zip, but also our line in business applications. And what we've learned, especially in a banking environment, is that you need to install the agents at last of your deployment. So for example, if you deploy DLP, it's data leakage protection at first, and it's not configured right. It wants to inspect everything what's happening on your builder VM, so the run can do 3 times as long as when you install it at the last action of your Packer build. And then you got the ceiling layer, and then you can, for example, use BizF and Citrix Optimizer to optimize your image, or when you do WVD, for example, to sys prep your image. So I think this is a lot of information, and for now it's the end of our session, and I hope you enjoy it. And if there are some questions, come in.
Yeah, so Patrick, you can read the chat. Are not really specific questions over there, but one of the attendees is asking whether DSC is considered as a method to deploy machines, so the desired state configuration.
Yeah, we definitely look into that. Like Terraform is just deploying resources. And you can use another tool like Ansible, or HashiCorp has its own tool, or maybe Microsoft desired state configuration to configure the deployed VM. So for example, if you want to deploy a domain controller, you can use, for example, Microsoft desired state configuration to actually configure your domain, your deployed resource with Terraform, only then with desired state configuration.
Yeah. So one question whether or not whether you are looking to MSIX AppAttach and its general availability when it's coming, will it be implemented, etc.
Yeah. What we try to do with the implementation is that we prepare the installation script where there's no intelligence, that we can reuse it when the MSI AppAttach is GA, and we are trying to generate somehow the MSIX AppAttach packages via a pipeline.
But still, the bank has 6,500 applications. So for the new ones, that would be a possibility. So we prepared that we can adjust that to that. So it's flexible, and that's a good thing.
Yeah.
Yeah, and we're also looking for some kind of way to, because our customer is heavily using SCCM, to look into SCCM and just grab out all the silent parameters from there and the repository to reuse that with Packer, and then from a pipeline, for example.
Yeah, I assume there's a lot of knowledge in there about how to unattended install stuff, which you can actually reuse in that case. Yeah.
Exactly, and we also in our customer there is a special packaging department, and we are not a packaging department, and I think it's like 3,000 to 4,000 applications in there, a lot. Yeah, and we don't want to do shadow IT here.
No.
Oh, great. Hey, there are no further questions in the chat. If people still want to ask a question, please unmute yourself and ask it directly. I also think that both you and Patrick and Rick, your contact details are in the slides, which we will share, of course, as well. But if there are no further questions, I think I want to hand over the presentation to Peter to finish up. And then we're almost ready for dinner then, in that case.
Cool.
I need to start cooking, so.
Okay, thanks for having us, guys.
Yeah, not a problem. Thanks
Thank you
for joining us. Let me quickly present and to finish up. Yeah, thanks for joining us. Hope we can do this another time on premises somewhere. Thanks for our sponsors, and thank you everybody for joining us Tuesday afternoon. Like I said, next week we have the Ask Us Anything, and in 2 weeks we have the next Workplace NIAS webinar with Dirk-Jan Mollema, and he's a researcher of Azure Active Directory, or only Active Directory, both, of Foxit T. So this hopefully will be a deep dive in that area. So thanks for our sponsors, and thank you for joining us, and hope to see you next time. Bye bye.
Thanks all.